All right, this is lecture 6 from chapter 10, and the last set of the topics from this chapter are working on calculating molar mass. So this is using the information that we just learned in our last lecture about Avogadro's number and the atomic mass from the periodic table that we can use. So what is molar mass? Molar mass is the mass of 1 mole of any substance, whether it is an element or a compound. So we can figure out what molar mass is based on what we now know about Avogadro's number and the relationship of that to the atomic mass from the periodic table. So the units for molar mass are grams per mole. So it's pretty straightforward. So let's take a look at how this would work. So what is the molar mass of carbon? So if you take a look at the periodic table and we look up the atomic mass. Oh, I keep picking up my table. I can use this one. I don't know why I keep forgetting. So if we look at the periodic table, we look up the atomic mass. The atomic mass of carbon is 12.001. And so that means that the molar mass of carbon is going to be 12.011 grams per mole. So if we are going to look at it in something like an equation, we know that each mole of it that shows up in an equation is going to be 12.00 or 12.011 grams. So what about molecular oxygen? So molecular oxygen is referring to oxygen gas. So we're looking at O2. So if we take a look at the periodic table, we've got oxygen at 15.999. It's that third 9 that had us off, had me off in the calculation in that last video. So we're going to do 15.999, or very often we just round oxygen to 16. So we're going to eliminate that one for right now. And we're going to multiply it by 2. So that gets us a molecular mass for oxygen of 32 grams per mole. And don't ask me why they shorthand mole, because that's only 3 letters versus the 4. You can write MOLE, but very often it is shorthanded as MOL. So let's do water. So water, we've got H2O. So we know hydrogen is 2 because we've got 2 hydrogens, and it is 1 gram per mole because its atomic weight is 1. And we're going to add that to the 16 that we just looked up for oxygen. So that means that the molar mass for water is going to be 18 grams per mole. Okay. And this becomes really useful in chemical reactions. So let's take a look at how that might be helpful. So this is why we were looking up some of these. So 1 mole of carbon, 12 grams, plus 1 mole of oxygen, molecular oxygen, is 32 grams, is going to yield 1 mole of carbon dioxide at 44 grams. Oops, sorry. So if you look, as I pointed out in another video, you've got 44 grams on the product side. You've got 12 plus 32 on the reactant side. They equal. But this is also helpful when we start to do actual reactions in the real world, because we might not have 12 and 32 grams of these reactants. We might not need 44 grams of the product. And so what we can do is figure out if we only need, say, 22 grams of carbon dioxide. We can then figure out how much we need of the reactants so we don't have to waste reactants. So let's do a little bit of practice. So how many moles are there in 45.5 grams of chlorine gas? So what do we need to know? First, we need to know what the chemical formula for chlorine gas is. So we've seen it before. In fact, one of the things that you should keep in mind for all of the gases that are in this column, in fact, for all of the compounds that are in family 7, if they are by themselves, they are all going to have the same formula. They're all going to be, let me get back over. They're all going to be diatomic. So F2, Cl2, I2, if they're going to be by themselves because they need that one electron. And so they're going to share one electron in order to make the compound. The same is true for oxygen gas and nitrogen gas because they're going to need to fill those outer electrons. So then we need to figure out what is the molar weight or molar mass of chlorine gas. Well, if we look at the periodic table, again, so we look it up. So chlorine is 35.453. So 35, wait, did I type it in? No, okay, 35.453. So that is the molar, that's not the molar weight. Remember, that's just the grams. That's the atomic mass converted to grams per atom. Because remember, the atomic mass that's from the periodic table is per atom. So what do we need to do with this? We need to multiply it by 2. When you do that, in this case, I know I rounded, you get 71 grams per mole for the molar weight, molar mass. So now that we have the molar mass, what are we going to do to figure out how many moles there are in 45.5 grams of chlorine? So we're going to take 45.5 and divide it by 71. That's going to give us 0.64 moles. So that's how you're going to solve a problem like this. You have to figure out first, if the formula is not given to you, figure out what the chemical formula is, then figure out the molar mass, and then you can back calculate how many moles there are in that sample. So remember, back again to the coefficients, remember that those coefficients show you the number of moles that are needed in a chemical reaction. So we're looking at the same reaction that we had before with hydrogen, oxygen, and water. So like I said, this is helpful in the real world because maybe we need to make more or less of the product, or maybe we don't have enough of reactant and we want to know how much we can make of a product. So we can figure out what these are based on the atomic mass that we can convert to molar mass, and then we can figure out the ratios and figure out what we need based on what's in the formula. So, for example, got some practice ones here. These are all kinds of different ones that I've got for practice. So this is just looking at, again, Avogadro's number. So we've got 100% silver chain. It has a mass of 107 grams. How many silver atoms are in the chain? So I will let you work on that one. If you need the solution or want me to work through the solution, you can shoot me an email. I can put up a video for you on how to do that one. What is the mass of 1 mole of sodium chloride? Again, I'll let you work on that one your own. This is the one that I want to work on. So how many grams of oxygen are needed to make 1 mole of water? And how many grams of water are produced by this reaction? So we're working on our reaction here. So this is actually the reaction that we saw before. So first, you need the equation. So in this case, I would give you the equation if it was an equation that I wasn't sure that you would know. So first, we want to know how many grams of oxygen are needed to make 1 mole of H2O. Now, we've got on that previous slide the whole equation, but with all the numbers, but we can't actually use all of that necessarily. So let's take a look at what's here. So again, we can figure this out. So we've got 2 moles of hydrogen, we've got 2 moles of water, but let's just go ahead and figure out what the molar mass is of each of these compounds or elements. Okay, so the molar mass of these guys right here, the hydrogen, is again 2. The molar mass of molecular oxygen, we know, is 32. And the molecular mass of water is 2 plus 16. All right, so 18. All right. So what we need to know, we've got the molecular masses for each of the compounds. We know how many moles this reaction makes of everything. So now we can go back to the question. How many grams of oxygen are needed to make 1 mole of water? So if we look at the equation tells us that we're making 2 moles of water to every 1 mole of oxygen, right? So if we only want to make 1 mole of water, and this is where I was talking about that this is helpful if we don't want to make as much, we need to know how much we need of another ingredient. Well, if we want to only make 1 mole of water, what do we need to do to the oxygen? We're going to need to divide by 2. Because we need half as much of the oxygen to make half as much of the water. And so that's going to get us 16 grams of oxygen needed to make 1 mole of water. Okay. So then the next question is, how many grams of water are produced by this reaction? So by this reaction here, well, we figured out the molar mass for the previous question. And all we need to do is then take the number of moles. So the number of moles is the coefficient, and multiply our molar mass by the number of moles, which gets us 36. Okay, that's not a 9, that's a grams. All right, so that is the end of this chapter. I am going to put up some more practice questions of this last part of working on figuring out number of moles needed, number of grams needed using different equations, because this video only has the one. I'll put up some other practice ones with me working them out, and then just practice ones to work on.